Alrighty, so let's take a look at this. Overall, how did it go with your answers? Good, bad, in the middle? Okay, good. Well, the good thing with this is these are the only equations we're ever going to be dealing with. These, and then, you know, the others that are on your sheet that we're not going to be using quite as often. These are the main ones. So let's take a look at the question real quick, and then we'll jump into the homework. All right, a rock is thrown straight up and it gets to the exact top of its path. What is the magnitude of its velocity and acceleration at that point? What do you think?
Velocity is 0 and acceleration is negative.
Negative what? Exactly. So when you're dealing with velocity, velocity is just how fast the object is going. So if it's going up and it reaches the top of its path, at that instant where it's turning around to go back down, yeah, its velocity is going to momentarily be 0. But what is not going to change is the acceleration of the object. Whether it's slowing down going up, or speeding up going down, or anything in between, if an object is in free fall, its acceleration due to gravity is 9.8 meters per second squared. That will never ever change, even for the tiny momentary pause when it's in the air and it's turning around. Acceleration is always going to be that value. So the good thing about that too then is we automatically know what acceleration is for all these equations. It's always going to be negative 9.8. So, anybody ever think about why it is that you never see a grumpy frog? That's good. I think I like that better than my answer.
Wait, what did he say?
Riveting.
Yeah.
Oh, that's fine.
That is good.
That is,
Man, I don't know if I should even give the answer. Puts me to shame. I was just going to say that they just eat whatever bugs them.
Oh my.
Okay. Yeah, I like Dylan's better. So let's take a look at number 4. So number 4 says a marble is dropped from a bridge and it hits the water in 6 seconds. And we got to calculate some stuff by that. Again, these are the main equations we'll be looking at for these questions. The first thing I do if I'm solving these is I want to write down everything that I know. So I know that it takes 6 seconds to hit the water. So t is equal to 6 seconds. Do I know anything else? No, one more thing. Yeah, I know the acceleration. That's negative 9.8. And yeah, I think that's everything. Except, yeah, what Sam said is it does eventually hit the water. So we do have an impact spot there, which means that what I'm going to do is I'm going to set my ground equal to 0, and I'm going to set the release height equal to whatever that change in height is. So letter A, we're looking for the velocity once it hits the water. So if we're looking for that velocity, I'm going to look not at this equation because this was an original velocity. If I look at this equation, well, I mean, it solves for velocity, but I don't know what my change in height is. So this doesn't work either. So I'm going to use this guy. And so now it's just a matter of putting the numbers in there. So for all these problems, it says I have free fall with an original velocity equal to 0. So original velocity is 0. Acceleration is negative 9.8. Time is 6 seconds. So you just do a little bit of multiplication. And your velocity then is going to be equal to negative 58.8. Thank you. Oh, yeah, fine. Yep, go ahead. Any questions on 4A? Okay. 4B says, find the height of the bridge. So if I'm looking for height, I got to use either this equation or this one because these are the only two that have change in height. So it's giving me time because it takes 6 seconds to hit the water. So what that means is that I'm going to use the top one, not the bottom, because the bottom one is an equation that we usually use if we don't have time. So because we have it, I'm going to go to the top. I'm also going to use a different color. Okay, so we do know the impact spot. We know it has an impact location. So my final height is going to be equal to 0. The impact spot is equal to a height of 0. Original velocity, that's going to be 0 because it's just being released from rest. Again, it says that on the top for the first 4 problems there. So this is all that's left here. We know the acceleration, that's negative 9.8. We know time is 6 seconds. So if I want to isolate that original height, it's like moving the 1/2 AT squared to the other side, which would make it negative. And then we just plug those values in. And the negatives are going to cancel, which is nice of them. And we end up with a height of 176. And that's number 4. Questions on number 4? Okay, so yeah, it's all about just picking the right tool for the job. And if you pick the wrong one and you don't get anywhere, just try a different one. The other thing about this is making sure you keep your positives and negatives straight. That can be a source of some issues too. So you do want to make sure, especially with your velocities, that you're keeping your positives and negatives in check. All right, let's do number 5. And the reason I'm going to do this one is because you basically use all 3 of these equations to solve a certain part of number 5. And the first part is something that we always have to keep in mind. 5a, this body, this rock, we're going to assume it's not like a human body. It is an object, we'll say, is thrown down with an original velocity of negative 20 meters per second on Earth. So now it's not just let go. It's actually thrown down with a certain velocity. So what I do know is I know the original velocity. I also know my acceleration. So I'm in wonderful shape so far. Now letter A, what is the acceleration of the object? Who can answer that for me? Yeah, negative 9.8. Even if an object is thrown down with some original velocity, it's still accelerating down at the same rate as everything else. Negative 9.8. So letter A is negative 9.8 meters per second squared. Letter B, what is its position after 4 seconds? So now it's giving us time. And we're looking for position. In other words, what is our y equal to? What is our height? So if I'm going to try and solve this one, I've got 2 options. I've got the bottom and I've got the top. Now it gives us information about time, so I'm not going to use the bottom one. I'm going to go with the top. Because usually if you have time information, you go with that top equation. So let's see where that takes us. Let's see. We do not have an impact point here. So what does that mean? We set equal to 0. Y-O or Y? Original height. Because if we don't know where it's going to land, it's easier to set the release height equal to 0. So if I'm looking for my position, I just hopefully have the rest of this information. And I do. Original velocity is negative 20. Time is 4. Acceleration is negative 9.8, and time again is 4. And when you run that calculation, you'll end up with a height of negative 158 meters. Plug and chug, as my high school physics teacher would say. You just plug those numbers in and the answer just pops right out. No force diagrams, no force equations. Nice and simple. As far as letter C goes, find the time required to reach a speed of negative 50 meters per second. So if I'm looking for a time, I'm probably going to look not here, because there's no time there. So I'm going to look up here or down there. So let's see. We're looking for the time when it reaches a speed of negative 50. So this equation up top does not take like a current velocity into account. It only takes a starting velocity into account. So I'm going to see if the middle one gets me anywhere. We'll use red here. Now, again, original velocity is negative 20. Acceleration's negative 9.8. And we know our final velocity is going to be negative 50. And we're ultimately looking for time here. How long does it take for this object to reach that negative 50 meters per second? So, we'll just use that equation over there. And we know all those numbers except time. Final velocity is negative 50. Original velocity is negative 20. Acceleration, negative 9.8. And it turns into a adorable math problem. So you just have to get the t all by itself. So I would add 20 to the left because that would make the negative positive when you move it over. And then, so that would be 50 plus negative 50 plus 20, so that'll be negative 30. So then negative 30 divided by negative 9.8 would get you your answer then. And that answer ends up being equal to, looks like 3.06. And there's your time. Plug and chug. And finally, we're going to take a look at letter D for this one. So letter D, now we're looking for the final velocity after it falls 100 meters. So now it's changing a little bit about what it's giving us. We still know the original velocity. The original velocity is negative 20. We still know the acceleration. That's still negative 9.8. But now we don't know what that final velocity is going to be equal to. But it does give us a little bit extra information. It tells us we've fallen 100 meters. So that means, let's see here, if we've fallen 100 meters, it's like saying our change in height y is equal to negative 100 meters. And you can probably guess which equation we got to use here. We have no information at all about time. So I'm going to jump straight to this bottom equation right there, and hopefully that works for us. So again, we're looking for that final velocity. Original velocity is negative 20. Plus 2. Acceleration is negative 9.8. And our change in height y is going to be negative 100. You do have to recognize that that's going to be a negative number because we have gone down 100 meters. So there's our equation, but the answer would be v squared. So what do I got to do to fix that? Square root it, exactly. So If I want this to be equal to regular v, I erase the square, and then I have to square root this side over here. And if you do that, you'll end up with a beautiful number of negative 48.6. Now, when you run this calculation, you get positive 48.6. What gives me the right to change it to a negative number? Going down, that's true, but what mathematical concept allows me to do that? Plus or minus, yeah. Yeah, because we're taking the square root, the result can be plus or minus. And I'm going to pick minus because I know the object's going down. And that's number 5.
Makes sense.
Yeah. So let's take a look at the main event here. That's number 7. This one's a bit of a beast. We better use blue.
One of those problems.
Yeah. So, it's a shame that we're skipping the one where the Jersey Shore people are shot down out of a cannon. But that's okay.
No, it's not.
Number 7. A kid drops a rock off the edge of a cliff. It takes 4 seconds to reach the ground. But when he actually throws the rock down, it only takes 3 seconds to hit the ground. What original velocity did he give the rock? Now you can see the answer is negative 11.4. I know at least one person got the correct answer. Did anybody else? 2? Cool. Sarah and Dylan, you guys rock. This is a tough, tough problem. So, let's take a look at this. If we want to figure out how fast he's actually throwing this rock, I'm not going to go with this because it gives us information about time. It also does not give us information about original velocity. If I want to find final velocity, I would have to know what that original velocity is. So that's out. This one, it does not take into account, let's see here. It takes into account time, but once again, we don't know the original velocity he's giving it. So this equation's out. So our last hope lies with that top equation, and we'll just see where it takes us. Now we know a couple of things about this. We know that the first time he just lets it go, maybe they say that's T1, that's equal to 4 seconds when he just drops it. But if he throws it, it takes 3 seconds to hit the ground. We also know acceleration is negative 9.8. So we've got that in our back pocket. But that's all we know. So let's just see what happens here. We know it's going to hit the ground. We know that there is an impact location. So what that means is that we are going to set our final height equal to 0. Original velocity is what we're looking for. Acceleration is negative 9.8. And time is going to be 3 seconds, because we're looking for how fast he actually threw it down. So this is 3, negative 9.8, 3. We're so close, folks. We've got one equation with 2 unknowns. We don't know original height, and we don't know original velocity. This is ultimately what we want to find. So in order to find this original velocity, we got to know how high up the cliff is. So we can actually figure that out based on the fact that it took 4 seconds for that rock to hit the ground when he just let it go. So, use a different color. Green. So if I want to find out this height, I'm going to use this equation again, but for the condition for when he's just letting it go and he's not throwing it down. So when he's just letting it go, again, we know that it impacts. So final height is 0. When he just lets it go, the original velocity is also equal to 0. And now we've got something that we can solve. So if we move the 1/2 AT squared to the other side, it boils down to that same thing we saw a little bit earlier, negative 1/2 AT squared. So if I want to solve for that original height, I'll just plug those numbers in. And for when he just let it go and when he dropped it, that took 4 seconds to hit the ground. So when you plug those numbers in, you get a cliff height of 78.4 meters. So now we can pretty much finish it up from here. Once you have your 78.4 meters, you can take that, and that then goes in for the original height. Time again is going to be 3 seconds for when he throws it down, as it goes down faster. Acceleration is negative 9.8, and time again is 3, and that would be squared there. So now you've got one equation with one unknown, a little bit of fancy math, and you can find your way to the solution, which is negative 11.4. Yeah?
I was thinking 78.4 from half times 9.8 times 4. You didn't.
Oh, yeah. This should be squared.
Oh, okay.
Yep. So yeah, when you run that, you get 78.4. Questions on 7? Okay. And as I mentioned, the more you practice this, the more you're going to get used to figuring out which equations to start with, and the smoother this whole process is going to be. So, I'm going to come around and collect your paper shortly, but I do want to do one more quick thing before we adjourn for the day. I want to see if you can solve something. I throw something straight up in the air at 20 meters per second. I'd like you to try and figure out how to tell me what the maximum height is going to be. How high is this object going to go from where I release it? You can use just these equations. See if you can figure that out while I come and collect your worksheets. I just need the part that I start. Let me go and find it. Thank you. Oh. Thank you. Oh, okay. Yeah, just turn that in when you're ready. Try and finish up in the next 30 seconds. Okay, did anybody get 20.4 meters? No? 1. Okay, perfect. So let's take a look at this one. This is another little concept that we have to make sure that we're aware of, kind of like how acceleration is always negative 9.8. So if I'm looking for how high this object goes, I didn't give you any information about time. So immediately my mind goes here. So let's see what happens. So if I'm looking for that change in height, my final velocity, what's that final velocity going to be when it reaches its maximum height? 0, yeah. So when you reach your maximum height, this velocity is nothing. Kind of like the question we had at the beginning of class. Original velocity is 20 plus 2. Acceleration is still negative 9.8. And then you would solve for your change in height, y. So you, what's that? Yeah. So then we just shift this 20 squared, I think that's 400. So that would go over here and it would be negative. Divide that by 19.6, it looks like, negative 19.6. And then that would get you your change in height, and that would be equal to 20.4 meters. Now, I do have 2 minutes, and I want to point something else out to you with this. Let's say that instead of throwing it straight up at 20 meters per second, I throw it at a 60-degree angle, right? At 20 meters per second. Maybe then I want to figure out exactly how high up it goes. Let me just show you exactly how you would do that, because it's not as complicated as it looks. So if you want to figure out how high up it's going to go here, basically you can use this exact same equation, but you're not going to use 20 meters per second, because it's not going straight up at 20 meters per second anymore. What you'd have to do is use your knowledge about triangles to figure out exactly how fast vertically it's traveling. So you'd have to use, looks like in this case you'd use sine in order to figure out this side of the triangle. So I'm going to, if you guys could do this for me, I'll just write it out. So it looks like sine of 60 is equal to opposite, I'll call it velocity in the y direction, over hypotenuse, which is 20. So can somebody do 20 times the sine of 60 for me? 17.32. So what that means is that 17.3 or 17.32 would go right there. So instead of this being some big complicated problem, all you do is you would take 17.3 and you'd use that instead of 20 in this whole process. Yep, it's the exact same thing. Once you find how fast your object is traveling up, then you've got all the information you need. So you do have to remember a little bit about sine and cosine. All right. See you tomorrow. Happy Monday, everybody.